Hi there. I decided to put this solution of this question in graphic form. Therefore, I had to use video and kind of access the board because the regular answering platform does not have the capability of video or graphics. So that's what I'm doing here. Just want to explain this for you. You got this guy here. His name is Helmuts. I'll just put his name here, H. He's standing at this point, and he's looking at the top of this building at an angle of 32 degrees. Okay? And the problem statement says that Ellis, who's here, I'll call that E, is standing 105 feet closer to the building. Therefore, the distance from here to here is 105 feet. Okay, this is important because we're going to use that. So, says that Ellis is standing at a distance of 105 feet closer to the building. So, she's 105 feet closer to the building. Doesn't mean that she's 105 feet from the building, but it means that she's 105 feet closer to the building. Therefore, that distance between Helmut and Ellis is 105 feet right here. Okay? And you know that this is a 90-degree angle. So, and they want the height of the building. It's simple trigonometry, but I'll explain it a little bit further, and some geometry in it too. Now you know that both of these angles here are 180 degrees. So that means that this angle here is going to be 140 degrees. Okay. Oh yeah, before I forget, the Ellis is also standing 40 degree. She has an angle of 40 degree to the top of the building. So that's at 40 degree right here. Okay. So you know that the sum of both of these angles is supplementary angles, 180. Therefore, this is 140 degrees. You also know that the sum of this angle here, this angle is equal to the sum of the two interior angles. So if you call this angle X here, and from simple geometry, 40 is equal to 32 plus X. Solving for X, X is equal to 8 degrees. So this will be 8 degrees. Okay. Now, you do not know the distance between Ellis and the building. That you don't know. You also don't know this angle here. But this angle can also be determined because if you take this triangle, I call that HEB. I'll call this O since it's the origin of the building. The angle BEO is 40 degrees. This is 90. And you know that the sum of all the angles in triangle EBO should be 180. Therefore, you can find this angle. Let's call this angle alpha. Angle alpha plus 40 degrees plus 90 degrees equal to 180. Okay. So solving for alpha, you get 180 minus 90 minus 40, you get 50 degrees. So this alpha angle here is 50 degrees. A quick check. The sum of the angles in triangle BHO should also be 180 degrees. So if this is 32 and this is 90, that gives you what? 132, and this is 90. 32 plus 90 gives you 122 degrees. So this whole thing should be 58, and this is 8, therefore this is confirmed to be 50 degrees. Okay. So now we haven't done any trigonometry yet. This is just geometry right now, just trying to figure angles and stuff. Now we're going to do some we're going to do some basically more math than it is trigonometry, but we're going to have to solve for this hypotenuse here. Okay. Once we solve for that hypotenuse length, we should be able to determine the rest of this, because this hypotenuse is common to triangle HEB and BHO, if you get what I'm saying. Okay, so if I can determine this hypotenuse, then I've determined the hypotenuse for the bigger angle. So what is the hypotenuse here equal to? Well, this is a irregular shaped triangle, but we know all the angles, 8, 32, and 140. We can use the law of sines in order to find the length of hypotenuse HB. Okay, so for the law of sines will be the side divided by the opposite angle, sine of the opposite angle equal to a side divided by the sine of opposite angle. We know this side, it's 105 degrees, 105 feet, and we know this angle is 8. Therefore, we can write 8 over sine we can write 105 feet over sine 8 according to law of sines is equal to the hypotenuse, which we do not know, which HB, hypotenuse HB, divided by sine 140. Okay. So now we find HB equal to sine 140 times 105 over sine 8. So sine 140 times 105 feet divided by sine 8. Let's see how much would that give us. Well, I already calculated this and I came up with 400. Let's see, just to make sure. Sine 140 times 105 over sine 8. I got 484.95 feet. 484.95 feet. So HB, the length of the hypotenuse, is 484.95 feet. So now, if we look at triangle here, I'm gonna draw it in different colors so you can see it. It's there, but I want to draw it in red so you can see it better. If you look at this triangle now, okay, we know what this angle is, and we know what this hypotenuse is. So, and we know this angle. So if we take cosine of 32, so cosine, write in black. So cosine of 32, cosine of 32 degrees is equal to adjacent, which is what's adjacent? It's HO over what? Over the hypotenuse. The hypotenuse, we know what it is. It's 484.95 feet. So now we can compute the adjacent HO, which is the base of this triangle in red. It's 484.95 times cosine 32 times cosine 32. You get 411.26 feet. Now you know the whole length of HO, and I'm going to write it down here, 411.36 feet. Well, if we want now the height of the building, it's nothing but the opposite of this triangle HBO. Okay, so if we take the tangent of 32, tangent of 32 degrees is equal to h, which we do not know what it is, and we're going to find it, divided by the opposite, divided by the adjacent, which is 411.36. And therefore, h is equal to 411.36 times tangent 32. .36 times tangent 32 for 11 point. Oh, sorry. This answer is for 11.26. 26. Correct this. Times tangent 32, you're gonna get 259.98 feet is the height of the building. H equals 259.98 feet. I'm just going to make a quick check on the calculation. Okay. This is actually 256.98. 256.98. I think you said the answer was 256.99. We're not going to fight about 0.01 feet. And that is your solution. If you like what you see, you could contact me on the Wyzant and set up lesson. Okay? Take care. Bye.